Okay, so our first topic, now this is a continuation. Kind of funny the way we break up the course, I know, into two halves in the summer like this, but uh, you started already looking at creating different types of database objects. You've been doing, of course, tables and views, but then into your functions and so on. So the next topic we're going to talk about are triggers. Now, triggers are a little unique from most of the other ones that you've looked at so far, right? A trigger happens automatically. You will never actually call a trigger to execute. It happens in response to events, right? Now, there's a couple different classifications of events, and we'll get into more of the details, but basically DDL and DML. Does anyone remember what those alphabet soup number letters stand for? DDL? It was mentioned earlier in the course, and I wouldn't necessarily expect you to remember. Data definition language. Those are the queries we write to create objects, like create table, alter view, and so on, right? Those are DDL commands. DML is data manipulation language queries, right? So that's our inserts, our updates, and deletes, where we're manipulating the actual data stored inside the tables, right? So DDL events like creating, altering, dropping objects, and then DML is to do with records, inserting, updating, and deleting. Well, we can have triggers for both kinds of events, okay? So DDL triggers are typically used by, hey, the boss, right? That system administrator that looks after the whole database system. Why? Because they want to usually keep track of and perhaps log what changes are being made by their whole team of developers, database developers they have working for them, right? So they, whether it's for that or just auditing purposes, right? I'm not saying it's just for the boss to spy on you, right? But there's legitimate reasons why you need to keep track of what changes are happening to the schema, the overall design of the system itself, right? So that's what they're typically used for, because you can usually inside the trigger then, add data into a log file or table, something like that of, hey, this change was made to this object at this time by such and such a person and so on, right? Data manipulation language triggers, okay, these are ones where messing around with the actual data stored inside the database, basically are used for a number of different reasons, okay? It mentions here maintaining integrity constraints, okay? Capturing audit information about changes to data, things like that. And, we'll look at a number of examples of the kind of things you might use a DML trigger for, right? What's unique about them compared to all the other objects we'll learn about is there's no parameters, input or output, okay? It's just a bunch of lines of code that you can carry out as an event triggers it to happen, okay? So they only happen in response to those commands, okay? You can't directly access them or cause them to run, okay? And of course, anything that runs automatically in response to an event will slow down the system, right? So you don't want to burden your system with unnecessary triggers, that's for sure. Okay, you only put them in where you really, really need them, okay? And the mentions there, we wouldn't want to rely on these for referential integrity. There are better ways to do that, okay? And you already learned most of them by actually, creating things like primary foreign key relationships and things like that. All right, so a DDL trigger, those ones that track the changes to the schema of the database, the objects themselves, right? They can be on either, okay, all databases on the server or one particular database, right? Those are your two choices there. Now for the event type list, like when you download this PowerPoint slide, you'll see that there's some links in the next slide over. So I've got some references there you can click on and find out how to ask, because it's different for different servers, right? What are the events that I can respond to? There's quite a long list, okay, for the DDL triggers especially, right? And then you just say as and then have the statements of what you want to happen when this event is actually triggered, right? Okay. Now, just to break it down a little bit, the on clause specifies the scope of the trigger, right? So, as I said, it could be the entire server or it could be just one individual database, right? Examples of things like create table, drop table, and so on and so forth, okay? But there's many, many more. There's, events for every type of object as well, right? So, basically, you can write any kind of commands you want for the trigger statements, okay? And there's a link there to a nice tutorial that goes through some examples, but we'll do some together in a few minutes as well, right? Now, guess what? Modify, okay? You've seen this already. You can create things, and then once it's created, you usually say alter. Alter is the command to modify it. One thing that's pretty much universally true with SQL is when you alter something, you still give a complete definition, right? You don't just say, go into this little bit of the code and change this one thing. No, you just redefine the entire chunk of code itself, right? So that's what you provide as a new version altogether. By the way, have you noticed that you can, instead of deciding create versus alter, you can say create or alter? Oh, it's cheating though. That's cheating. You don't have to think about it, right? Because it'll just create it if it's not there and alter it if it is. So, oh, well, I gave the cat out of the bag now, so you know how to cheat on the test. Sorry. I guess that's not really cheating, is it? Okay. All right. And of course, we'll get error messages if it tries to do something that it doesn't allow, right? Or if you try to do something on a trigger that doesn't exist, okay? Or an object that doesn't exist. And of course, dropping triggers, well, that's obvious, right? That's the easiest one, is always dropping things. And away we go. Now, another thing is we can, without dropping a trigger, we can temporarily, usually it's done temporarily, disable a trigger, right? So if you have something that's going to fire for every operation, you're about to do a big bulk update of something, right? Then you might disable a trigger temporarily, right? Especially with DML triggers. So you might have a massive import of data you're about to do. Hundreds of thousands of records, right? Well, if there's a trigger that fires for every single insert that might happen in a bulk import of data, well, that's going to tremendously slow down the system. So assuming in a case like that, you've probably already done some work to sanitize the data you're about to import, right? So you know it's safe to do so. Then it's very typical. We would disable the trigger temporarily, do our import of data, and then re-enable it afterwards. Just don't forget to re-enable it when you're done, right? So that's a useful thing that we can turn them on and turn them off, basically. Right? So I'll tell you right now, there won't be anything on the test on DDL triggers, right? But we will do a demo just so you have some familiarity with it. Our focus in this course is going to be on the more commonly used DML triggers, right? The ones where we're responding to insert, update, and delete events, okay? So they're basically it's the same create trigger command, okay, but it's always done in one database, right? You can't create it because it's for a specific object, right? And objects live in one database, right? So it can either be a table or a view, okay? That's the only two things you can create triggers on is tables and views, right? And then our choices for the type of trigger is basically after. By the way, for backwards compatibility, it used to be earlier on, they used the keyword for, right, for an event, okay? They've gotten away from that because it was a little confusing because people didn't always understand that the trigger always happens after the triggering event is done, right? Mind you, you're still inside the transaction. You've done work with transactions now. Am I correct? Yeah, okay, good. So a few nods around the room, good. Okay, so you may not know it, but absolutely everything you do is always inside a transaction. If you do a single command, you know, it's still inside a transaction, right? There's different modes you can have on, you know, you can set it so that everything in a session is in one big transaction, so you can roll it back all at once, but by default, every individual command you make is in its own transaction. So it's pretty easy to understand that the trigger would be part of the triggering event transaction. So that's something we can always do is we can always say, hey, I'm not happy with the changes being made in my data, so I can just say rollback transaction. And it will reverse whatever was done in that triggering event, right? So that's really one of the powerful things about triggers. You can say, you're not allowed to do that, and put the data back again the way it was, right? So after trigger, they prefer to use that word now, because it kind of makes it clear that this is happening after the event has already taken place. Can anybody imagine what we might have a use for an instead of trigger? Well, the most common thing I've encountered for an instead of trigger, remember it says we can do triggers on tables and views, right? Can you normally insert data into a view? Yes, but it's not easy, especially if that view involves a join, right? many of our views we create, we have, inner join this to this table and an inner join again, and you might have a whole bunch of tables all involved in one view that you're pulling data in a large select with lots of joins and so on. Well, you can't start inserting data. I know when you talked about transactions, you probably did a scenario where you wanted to insert a new, let's use an example, a new employee. Every employee has to be in a department, right? It's a required foreign key that there's a department ID for the employee. So you're hiring a new employee, but they happen to be in a new department. So in a transaction, you might have set it up as an exercise earlier in the course where you would start a transaction, create the new department, find out what the new primary key for that department was, go on and add the employee into the employee table, assigning them to the new department you just created. And if anything went wrong in the whole transaction, you'd roll it back, right? I suspect that might be the kind of example you've looked at before. So imagine if you have a view based on department and employee both tables. You can't insert directly without writing your own individual transaction, but you could make a trigger where instead of actually trying to insert anything, the instead of trigger will actually execute your code instead of the triggering event. It just gets basically ignored, and you take over and you do it manually in your own code, right? So the instead of trigger would let me insert directly into a view combining multiple tables as long as I do it in the kind of way you did with that transaction earlier. Maybe make the new department, find out what the ID is, insert the employee, and that could all be done instead of trying to insert directly into a view which wouldn't allow it, right? So that's an example of a instead of trigger. Okay. So the trigger name must be unique in the database because remember, DML triggers live in the one database. Okay. Of course, all the normal naming rules for any object will apply and so on and so forth. On specifies the name of the table or view, to which it's associated. And the event type list, is really just limited in this case to insert, update, and delete, right? After, that means that's the normal, instead of, well, we talked about that already. For, well, basically that's here for backward compatibility because you might have somebody who wrote queries many years ago and they use that keyword, which we now are encouraged to use after instead. All right. Now, so how does the code work inside these DML triggers? Often if we're going to do any logic, that logic will be based on knowing what the changes were that were happening here, whether it's an insert, an update, or a delete, right? If you're going to intervene and maybe make some additional changes or decide if this was okay or not, well, you got to know what data has been manipulated in this data manipulation action, right? So how we find that out are these two temporary system tables. Basically, they're actually named inserted and deleted. Now, you don't always have both. On an insert trigger, you'll only have the inserted table. But it has a snapshot then, a copy of the data that was inserted. If you're doing a delete trigger, you'll have the deleted temporary table. In an update trigger, you have both, right? It's like the old version and the new version, The old version will be the deleted temporary table, and the new version is the inserted temporary table. And because they're sitting there as tables, you can do a select. You can pull whatever information you want out of those inserted and deleted temporary tables, and then use that in some logic to decide what you want to do, right? So basically we'll often pull values into select statements into variables, and then have ifs and so on, right, to decide what actions we want to take. Okay. All right. Yeah, so that's just saying what I just said. Again, inserted is there for the insert trigger, and so on and so forth. It's only the update trigger you have both. Okay. So we're going to look at a few examples of triggers, then we'll do some more demos afterwards as well. But right in the PowerPoint I have a few examples, right? This is an example where we'll create a trigger on the employee table. Let's suppose we want to have a rule that's hard to do any other way that prevents users from deleting more than one employee at a time, right? We might have it set up that all of our stored procedures would only delete one employee at a time, but what if somebody goes in there and does delete from table is employee in this case, and they accidentally forget to add the where clause, right? You know what happens if you execute that command? It'll empty out the entire table, right? all records would be deleted if you don't have a where clause to specify at least, perhaps on the primary key which one you want to delete, right? So this trigger would prevent that from accidentally happening, and that's what we're going to look after, okay? So it might look something like this. Create trigger, right? Now, whatever prefix you want to use, you'll see in most of our PowerPoint slides and so on, TR underscore uses a prefix to indicate, in the name of the object, what kind of an object it is, right? Really not the end of the world if you don't use prefixes like this, but it's kind of a common practice. But if you want to use TRG or something else, I don't really care, right? I'm not strict on one particular acronym versus another. On employee, now that part has to be correct, right, on the table you want. Oh, before I leave it though, the only other thing I should say about the name of this trigger is, of course, every trigger must have a unique name, right, in the database itself. So it's going to be after delete, and here we can do a select count star from what temporary system table? The deleted table. It's a delete trigger, so that's the one that has a copy of the data that was just deleted, right? Now it won't have a copy of the entire table's data, just the record or records affected by the triggering action, right? So we can count how many records were deleted with that simple select, and if it's more than one, we can say, okay? We can raise an error, give an error message that'll show up in the console, right? And by the way, client applications also have a way to access that error information, right? So it's useful not just on the screen in front of you, right? There's a severity issue there. 16 is about halfway in the range of severities you can specify, and so on. But the most important thing is that next line, rollback transaction, right? Because we're in the same transaction as the triggering event, when we say rollback transaction, it would actually reverse the operation of deleting whatever data was being deleted because we tried to do more than one, right? Understand? Pretty straightforward. Okay, good. Lots of nods around the room. I'd love to see that. Okay. Now, if we were going to alter this trigger, all we have to do is say alter trigger. Maybe we've decided, you know what? We're going to allow multiple deletes, but with a limit of 6. Okay? It gets away from the danger of deleting everybody at once, but there are times when we do want to delete more than one at a time. So we're going to change it to 6, right? So again, I emphasized earlier that any time you're altering anything, whether it's a view or a trigger in this case, we basically just repeat the entire definition, give it a new definition of the trigger itself, right? Obviously, we just change the logic there as well as the error message being given, right? Okay. Now, one other thing that's useful, we mentioned that in a update trigger, you have both the inserted and deleted temporary tables. So you could do some selects, pull values into variables and do comparisons and so on. But something, because it's so commonly done in an update trigger, a nice little feature they've added for us is this simple command here. We can just say if update and pass in the name of one at a time field, okay, or property, whichever term you like to use, right? And that way it checks if this was in this case here, it's set up for the last name. The idea is that we are going to let you change anything about the record except the last name. Pretty stupid example. People get married, and the most common thing they change is the last name, right? Anyway, all right, that's an example. It works, right? So we're checking if they've updated the last name. In that case, we're going to roll back to the transaction, right? You can update anything else you want, but just not the last name, right? So it's just the update command here allows us, or it's like a little function really, allows us to quickly test without having to separately write selects and pull out the old version of the last name and the new version and compare them. Okay, and again, just like DDL triggers, the DML triggers can be enabled and disabled as well, right? Okay. All right, we can drop a trigger, of course. Okay. Now, to find out what triggers you have in your system, if you want to do it from command line, we have a few different commands we can use, right? Of course, SP depends, we pass in the table name, and it will tell us all kinds of information about what objects depend on that table, and in there, it'll mention what triggers are on the table, right? I encourage you to try these out on your own in SQL Server Management Studio and see what information they give you. Obviously, maybe after you've created a trigger, so you can see what it is. SP help text with the actual name of the trigger we'll actually show you the definition of the trigger, right? The actual code that was written as it was created, including any comments that you added in the code and so on as well, right? And help trigger as a built-in stored procedure. Did I explain what SP underscore? Have you used that before? It's a built-in stored procedure. It's part of the actual system itself, right? So these are there as just built-in commands, you might say. Okay. So help trigger, again, you pass the table name, not the trigger name, and just determines, instead of everything about SP depends, it just tells you what triggers exist on a specific table and their actions, right? Okay. All right. So just to kind of summarize here, common usages of our DML triggers, because those are the ones we're really going to focus on most. Those are the ones that will be on the test coming up, right? Most common usage, enforcing advanced rules, constraints, things like that. Now remember, we don't use them for referential integrity. That's already built in with our the built-in referential integrity constraints, right? But more advanced things, right? I've got an example here. Suppose that, we have in our school here, we have enrollment. Maybe we have 100 students enrolled in this course. Right now we're divided into 3 sections. What if somebody somewhere made up a rule that, well, no more than 40% of the total enrollment can be in any one section? How would you enforce that rule in the database? Well, a trigger could do it, right? Because in an insert or in an update, even in a delete, right? Well, you wouldn't be too worried about a delete, most likely. But you could check, okay, and count the total number of students, right, with a select query. Check, okay, how many are in the section that you're maybe modifying because you're adding a student to a section, things like that, and determine if you're breaking this rule and roll back the transaction if you are, right? So that's just an example, a little bit more advanced example maybe, but that's the common usage of triggers, right? Another big one is denormalized data. Now, is that a new term to you, denormalized data? You probably talked about normalization, right? Normalization in a database is where you kind of optimize the performance of the database by saying, I like to put it in layman's terms like this, don't save the same information twice. Like, so, for example, one common thing is saving a name, first, middle, and last name separately. Why would, you've already got that. Why would you create a separate field to store a full name? You can always build it out of what's there, okay? And there's many other examples you could think of that, denormalized data. Well, let's get back to we talked about students enrolled in a section, right? So for the course, you might have to find out how many students are enrolled in a course, you can do a query. Group by, right, the course, sum up or count, whichever, how it's set up in your system, how many students are in it, right? Simple query. You could run that whenever you need to get that report of, what students are in each section or what employees are in each department, right? Grouping by department, counting the employees in the department, right? It's easy to find that out. What if you are in a system, though, where those reports are being run constantly? Picture a company where you've got way too many managers. And they love pulling all these reports all the time, and you think this is stupid. We're running these queries over and over again to produce these reports. It's not a big deal if you only have a few records, but what if you have big company with millions of records, right? Every time you run those queries and do all the grouping and ordering and summing and adding and counting and so on, it's a huge overhead on the system. So sometimes it can be more efficient to have some denormalized data, maybe for each department, have an actual field where you store the count of how many employees are in it, right? It seems counterintuitive, but depending on the circumstance, sometimes denormalized data is added for just that reason. If there's more querying happening, doing summary reports, so to speak, then there is data going into the system, then it might be useful to actually have that. It makes your performance better overall. All those managers that get their reports up on the screen so fast, and they are the ones that write your paycheck and sign it at the end of the week, right? You want them to be happy, so you might, in that circumstance, go ahead and do that denormalized data. Most of the time, though, in any system which is highly transactional, where there's data pouring in all the time, having a trigger to maintain that denormalized data is counterproductive because it really slows down. The most important aspect is getting the data in fast, right? And if at the end of the month, once a month, you run a big query over a large set of records to count how many employees are in the department, who cares, right? You just do it once a month. So there's no hard and fast rule if denormalized data is good or bad, right? Sometimes it's good, sometimes it's bad. It depends on the situation. But it's something that is very nicely handled if you want to use it with triggers, right? So that's sort of a summary of the discussion I just had with you about why would you want to store data that can be derived, right? Fast summary reports, which slows down data manipulation, but it's something we can easily do with a trigger. So basically think about adding a new employee to a department, right? Part of the trigger, if that insert into the department or into the employee table, you can go find out what department and go increment, add 1 to the existing value of the count of how many employees are in there. That can be done in the trigger, right? And that takes care of it automatically. That count of employees in the department maintains itself every time you insert, update, or delete employees, right? Okay. Trade-off depends on how the database is used, the amount of data stored, and so on and so forth. All right, so that's it. We're pulling the trigger on this topic. Sorry, that's my attempt at humor. I know you've probably only had 1 coffee so far today, so it's a little much to expect, but there you go.